How does a condenser work in mechanical refrigeration? Imagine a machine that keeps your food fresh and your air cool. It all comes down to a series of clever steps in a refrigeration cycle. One of the most important parts is the condenser. But how does it actually do its job? Let's find out. In a refrigeration system, the refrigerant starts as a high-pressure vapor after being compressed. It then flows into the condenser. The main role of the condenser is to get rid of the heat from this vapor. It acts like a heat exchanger, which means it transfers heat from the refrigerant to the outside air or water. This process is vital because it prepares the refrigerant for the next step, which is turning back into a liquid. The condenser performs three main tasks. First, it cools the superheated vapor down to its saturation temperature. This is called desuperheating. It's like cooling hot steam until it's just about to condense. Next, the vapor releases its latent heat and changes phase from a vapor into a liquid. This phase change happens at constant pressure and releases a lot of heat, which is then transferred to the surrounding environment. Finally, the liquid refrigerant is cooled further below its saturation temperature in a process called subcooling. This makes sure only liquid refrigerant, without any vapor, reaches the metering device, which helps the system run more efficiently. The heat removed from the refrigerant is transferred to a secondary medium. In air-cooled condensers, fans blow air over fins to increase surface area and improve heat transfer. Water-cooled condensers use water flowing through tubes around the refrigerant pipes. These designs use materials like copper or aluminum because they conduct heat well. The goal is to maximize heat transfer during the phase change, which is more efficient than just cooling a fluid without changing its phase. During condensation, the refrigerant's temperature stays nearly constant, which helps create a big temperature difference with the cooling medium. This difference makes heat transfer faster and more effective. The better the condenser works, the more efficient the entire refrigeration system becomes. It helps prevent the compressor from overheating, reduces energy use, and keeps everything running smoothly. In real-world applications, the design and size of the condenser depend on the system size, the type of refrigerant used, and environmental conditions. Proper maintenance and choosing the right type of condenser are key to keeping the system working at its best. So, in simple terms, the condenser cools and condenses the high-pressure vapor into liquid, removing the heat it absorbed and adding during compression, all through effective heat exchange methods based on the principles of thermodynamics.